Hey folks, we're here for another Toolbox, Stunt Rigging Toolbox talk. I haven't been as prolific as I have been in the last few years doing these because I've been really busy. And I'm going to actually take today to thank everybody who's watching. And people have been writing messages and writing emails. Hey, what's up? Da, 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 da. Yeah, it's called, it's a one-man shop. You know, it's like the old Mary Poppins movie with Dick Van Dyke being the one-man band. You know, or the little monkey. I've got the cymbals, the drums, the accordion, the whole thing myself. So if I'm not on the mill or the lathe, I'm on a show. If I'm on a show, I'm not on the mill and the lathe. And in between, I don't get YouTube bullshit done because it's like eats up time and it doesn't generate income. Anyway, I'm doing today on a very esoteric piece of equipment that's used in the stunt rigging industry. It's a mechanical form of rigging, but it allows for a lot of things. You use them with a lot of actors who don't have a real good physical presence or good physical knowledge of airspace, and you can puppet them to do really cool stuff. Basically, it's an actor on a popsicle stick. It's called a tuning fork. It's basically a shaft with a fork at the end, i.e. a U-shape bend at the end that allows them to somersault, and if you mount it with Sutra's spin rings, which you're all familiar with, they can rotate this way like an ice skater, they can flip, they can do any combinations of those moves. Plus on the end of the shaft, which is however long, we'll get to that in a second, you have a steering wheel, so you can turn them right, left, so literally you can drive them around. Now, there's as many flavors of tuning fork as you want to believe, and everybody tries to make one that's cool. There's super short, super light ones that are, super short, like 1.5 meters long. They use basically that just barely do the hip picks, and they can move people and rotate people, and people can do things in a very short, like fight action sequence. That's common. The more common use is longer versions, 2 meter, 3 meter, 4 meter, 5 meter, up to 6 meter, which you use to do green screen work and to separate the people operating from the, even though you're in a green suit usually anyway, separate the people from the performer. And we used a lot of these on Moon Knight. They were used heavily on Malevolent. They've been used on Superman. If you go through YouTube and look at that, you'll see a ton of different ones. But it always comes down to what your application is. There's no one size fits all, though there are basic engineering tenets that apply. I've heard of accidents where the heads snap off of them, and it's because you don't know your engineering and you build shit that doesn't work. The original ones, when I first became aware of tuning forks, was the original Matrix, and they had built, literally, they weighed 1.5 tons a piece, giant steel constructions with huge steering wheels to do a lot of this special spinny, twirly, fighty stuff. And we nicknamed them the Vomit Comets. And they took like 4 guys to operate minimum. They were huge, they were heavy, like I said, 1.5 tons. And they worked quite well. They were super stable. It's also before the days of stabilized cameras, so you had to really keep people more efficient stabilization like we have now. So you had to really keep the weight in them to keep a lot of fast and hardcore movements from juddering them around. And they were ground-based. Now you have a couple options with tuning forks. The Little Mermaid used a lot of tuning forks for the swimming stuff. People could look like they're swimming, dry for wet, in that position, cruising along, and people pushing them on ground-based supports. There's several people who are self-proclaimed experts in this, and everybody, as long as you're a good engineer, you can figure this shit out. It doesn't really take a lot. But there are some things that you have to pay attention to. One, because of the length, the weight at one end, steering at the other, and a support somewhere along, depending on your balance factor of what you're trying to achieve, where your bearing is, you end up with things bowing. So the smaller your diameter on your tubing, the more flex you have in your construction. Hence also the type of steel you use. You want a much sturdier steel. The problem is that the bigger diameter you go and the thicker wall you go, the heavier everything gets. So there's a self-defeating factor here. 50 mil tube doesn't really work well because it flexes a lot. If you take 5 meters of tube and you put 100-kilo weight in the middle of it, you'll see how much deflection you get. So when you put somebody up and you've got a counterweight on one side and them on the other, and it's either supported or suspended in the middle, you can see that the thing flex, which is not crucial as long as you're only doing this. But the minute you start rotating, they flop. They're not in a perfect circle. They go whoa. It's an ellipse. So that becomes an issue, and it generates a lot of extra force. Things tend to break that way. Little Mermaid used ground supports. Malevolent used ground support and hanging them. I used them a lot on Moon Knight, and we had most of the major actors in them, and I used them on giant, super steep slack lines because we motivated them a lot. We had 10, 20, 30-meter runs at speed with the actor performing, doing things from takeoff through flight, twisting, turning, and then landing. And we did that all in tuning forks with the actress. And other people. We had Ethan Hawke, we had a lot of people in these, and we did duo fighting and flying scenes with them this way on green. It makes things very, very containable. You can really work on them well. So some basics, and you've got to decide when you're doing a tuning fork, what's your purpose? How long does it need to be? Moon Knight, we needed to be way far away and they needed to be way high. So we ended up with 6-meter long main shafts. The reason I'm into this right now is I just finished building one that's finished now, and I'll be able to show some pieces and stuff. It's only 3 meters, which is kind of a nice middle ground because the fork itself adds another meter or more to the distance. So you have overall 4 meters, whereas with a 6-meter post and you add a couple meters on the nose, you end up with a 7+ meter length. They're cumbersome, to say the least. In the background, you can kind of see the foam padding for it, and you also see the steering wheel sitting there, which is I'll show you that in a minute. It's on a coupling. So basically, you could weld the whole structure up and then put a bearing captive on it and be good to go. The problem is you end up with this giant fuck off thing that you can't transport, you can't do anything with. So then you start figuring out how to make it modular. Okay, so a shaft is a shaft. Bearings are bearings. Now, the closer together you put the bearings, the more you point load your shaft, your main shaft. So it's going to flex more with a single point load. I tend to spread them out 300 millimeter or more, so you actually have less single point loading when you're supporting them either in the air or on the ground. The forks, if they're attached or welded to the main shaft, it's all hunky-dory, but then you're stuck with something that's, 70 centimeters wide by 2 meters or 1.5 meters long, that's stuck on the end of this popsicle stick, and it's welded there. You can't fucking do anything with it. You can't move it. You can't store it. You can't anything. It becomes a hassle. So we make the forks. I make them modular so that the fork section comes off. Now, this inherently makes problems because to be able to get something that's tight fitting on and off the main shaft and yet doesn't wonk around, you have to put adjusters in the couplings, and you have to pin them. And then, of course, if you pin stuff with most monkey stunt guys, they're going to reef everything down like overly tight so that you're going to egg the tubes. That means you have to put standoffs inside the tube so they can only tighten it so much it doesn't really matter what the fuck they do. They can't crush it. And then you also have to allow enough room to be able to slide it on and off, which is, it sounds like a big deal, but it's a few thousandths. All these are very, very tight tolerances. I mean, literally a few thou. So, making all this becomes very precise. So what I do now is I go for larger diameter main tubing for the last 3 or 4 I've made, which people are like, oh, that's huge. Well, it is, but it's only 2.5 millimeter wall. So the formula for rigidity and everything deals with the millipascals, the MPa of the tubing itself, and it's based on a surface area. So the larger diameter has more surface area, so you have more stiffness. Simple, put it in English, it's like a smaller diameter is not as stiff as a bigger diameter, even if it's the same wall thickness, okay? So I go for a larger diameter, thinner wall thickness, which is actually lighter than a smaller diameter, heavier wall thickness because it still flexes more. So we've opted for a larger shaft, and the bearings are in a housing that's a standoff of over 300 millimeter. So bearing here and a bearing here with a block in the middle that's actually a 8 millimeter plate machined housing that holds two bearings on the end, bolted in, and in the center where it's supported, either ground support or hung, I have a steel ring inside. Well, it's actually a block because the bearing housing's square, because I use industrial bearings that are easy to get, and working on rounds is a pain in the ass. So I got bearings that are square, so the housing is square, and it's a square steel insert in the middle. It's quite heavy duty. It has four 30-millimeter thread bosses in the middle of all four sides. So you can either hang it from 2 points on 2 slack lines. You can hang it from a single point on a 2-to-1 in the studio. You can ground mount it on a 30 mil bolt to a U-joint on a pedestal of some kind. The problem with all ground mounted units like this is because of their length and because of their weird height, the load's higher from the ground and it's moving, making a stable base is really difficult because they want to tip over. Four legs, with wheels doesn't move as nice as 3 legs with wheels. But if anybody's ridden a 3-wheel ATV, they know how easy they flip over. And a 4-wheel doesn't steer as well. So then you get into the whole design of a way to ground mount it. It becomes an issue. And how's it going to work? And how heavy does it need to be? And then once it's heavy, how can you move it? I mean, the ideal is something that's heavier than fuck all, that's tons of weight, not literally tons, but a shitload of weight close to the ground. On a stage floor, you build a tripod that bolts to a big base plate, and you put 4 air slides on it. But then you got air hoses and compressors to deal with, and these things move. I mean, you can move literally a tank with 4 air slides and push it around with one hand. So that becomes the ideal: zero friction, zero anything running against the floor. You don't feel a crack in the floor. You don't have to turn a caster wheel to get it oriented in the right direction. You could have them that has a steering wheel like the originals, and you can crab all 4 wheels in any direction you want. You can go straight, you can crab, but then that becomes a steerman, plus the guy's pushing, plus the guy's operating the thing. So you end up with a 6-man monkey fuck trying to deal with all this, and it weighs a ton. So these are all the parameters on a tuning fork that you got to pay attention to, and they become, trying to make one that's more useful than a single instance, meaning I have this requirement. So you build one to fit, but on the fork, what are you using? Are you using a spin ring, or are you using a super swivel harness? Now, both have different mounting and both require different widths. So one size doesn't fit all. You can make a different head, a different fork. You pull the fork off, put one for this, put one for that. But it doesn't have the size parameter changes. If you've got an actor that's X width at the hips and the next actor is X plus, you're fucked because nothing adjusts. So what I've done is I've make actually a single fork based on a certain size of ring that also has changeable modular billet machine heads that slip in and out of the forks and pin, so that you can go from either a super swivel to a ring and back again with the same fork. Literally, it's changing 2 bolts and 2 pieces of hardware at the end, and you're ready to go with a Sutra super swivel or a ring. It's whatever you choose. It's a lot of math and overlap, trying to figure out what works, what lengths, how strong is it going to be, because mine have blocks that have shafts that move in or out to hook to the super swivel. So you can set them however wide your hip picks are for your talent within a parameter. Okay, and the longer you make them, the more overhung load you get in the rotational direction with the performer, because so now you're twisting the tubing torsionally, and you're also supporting the load. So this also adds stress to your construction. The forks, myself, I either bend them or I multi-cut and weld. So I either do like 45s, is a simple way to say it. But I do several smaller cuts to create the round bend. Trying to bend them as one piece works, but you have to go with a heavy enough wall for the diameter that you don't wrinkle the tubing. And I have a race car cage bender, and I have to use 3.5 mil wall, which then becomes heavier than the 2.5 I'd rather use. So either way, I gusset the corners, I gusset everywhere where it goes. The collar is gusseted. Everything is built so that it resists torsional stress and it resists twisting stress, because you've got something that's overhung on the end of something, so it wants to do this. So where it comes across the mount, it's twisting, so you need to plate it on top and bottom so it can distribute the weight. It becomes a mechanical thing, it's just one of those deals. Novelty for me is I can do both. I mean, I know the rigging requirements and I also know the building requirements from doing enough metal work in cages and shit like that. And then of course there's the post-treatment on all your welding of post-weld heat treatment, annealing the welds, because as you weld shit, it gets hard and brittle. Your weld material you put in cools faster than the parent metal, and you have contractions and things change dimension. Anybody who's welded knows you weld something and it fucking warps like a potato chip. You better know what you're doing ahead of time and adjust for it and make sure you've set everything up. And even then it's not going to be perfect. And even then the heat affected zone, which is the next zone right next to where you've welded, is going to be brittle because you've changed the microcrystalline structure of the metal. So it's going to want to break not at the weld, which is stronger, but next to the weld. So you'll break the parent material unless you do something like take the hydrogen out of the weld by heat treating, or which is what I do. I heat treat them for a period of time to off-gas the hydrogen so you don't have a hydrogen breakage. And you also are annealing the brittle, hard material to a point where it relaxes it. I mean, it's common with race car frames. It's common with motorcycle frames. It's common with all these tubular structures that are built. And you can avoid all this distortion because you just lock them down in a fucking fixture and weld the shit out of them. The problem is if you weld too hot, you weld too much metal, all that, they're in there, they're straight in the fixture. The minute you undo them, they go pwang, and they turn into a potato chip. So what you do is you take them on that fixture while they're all locked in, and you heat them in the oven if it's small enough, or you heat them with a torch with temp sticks and mark how hot you're getting at each joint and bring them back to a relaxed in stasis point so that you're not adding additional stress to the material. All of this goes into building one of these fucking things. So, everybody says, oh, we'll just make a tuning fork. If they haven't considered all these problems, then, they're going to have problems. Or you can just overbuild the fuck out of it and it'll hold, but it's also going to weigh a ton. Now, mine, the tuning forks I make, I prefer to hang them. I hate base stations because, as I said, they become their own enemy of how to do all this shit. How to make them stable, how to make them not want to tip over. You've got a super high center of gravity. It becomes an issue. So I avoid them entirely unless they're stationary. And then you can have a base plate with a pedestal and put a U-joint on it and bolt it to this thing and do whatever you want. It just becomes a matter of geometry. How high do you have to take them? Does it have to be on risers? Do you need to put it up on a riser or a platform and then operate so you can bring the performer up and down? Are you going to need your own set of stairs and or / risers for you to climb up and down in the back? Because remember, it's a seesaw, kids. It's this and this. And when you hit the ground here, that's as high as they can fucking go unless you take it higher so you can do this more. So you start playing games with this. You start playing games with length. The longer it is, the higher you have to be able to get the angles. The shorter it is, the lower you can be and get the angles. And remember, your steering wheel is not some little thing like this because you have no leverage. You're moving a mass at the end. So it's like this. It's a meter, 900 millimeter or a meter. So you can actually function with the thing because you're rotating mass. So it's a dance between weight. It's a dance between strength. It's a dance between functionality. And we've got a modular system that will accomplish 90% of what you need. You'll be able to do front saltos. You'll be able to rotate in a ring. You'll be able to switch it to a swivel harness and be fine there. You'll be able to do either or with just simply plug and play. It's kind of our thing here with our ratchets, with everything we build, it's plug and play. I don't like fucking about, and I don't see a point in making 10 different pieces of equipment that achieve 10 different things when you can try to get it modular so that you pull a pin, you undo a bolt, you change the part, and you're good to go. It saves a lot of hassle. So anyway, tuning forks, 1A, basically green screen work and or large stage. You can watch it all online. It's all on various YouTube videos. But it's one of those weird, esoteric, flying, rigging things that we use to do a lot of these films, and it's kind of interesting. I mean, to me it is, because I've tried to perfect a style of these. And just remember, you've got the weight of your steel, the weight of your bearing block, your counterweights. It's a seesaw, kids. You put the fat kid on that end, you got to put the fat kid's weight on the other end so that you can keep it neutral. Otherwise, this becomes like anything, like a hand pull. You've got to make it so you can just puppet them up and down. So you've got to equalize, and that all depends on the length from the bearing pivot to the actor and the bearing pivot to your weights. So you've got to learn marks, and you got to learn how to do it, and you've got to learn a little bit about geometry, leverage, weight. It's basics physics. So these are all the things, and I'll do a quick look through of the parts. I'll go here. Let me see if I can turn this around without fucking it up entirely. You can see the board, and the board's just a quick diagram of a tuning fork. You have the main shaft, you have a collar that holds the fork, or you can weld it straight to it, but I don't believe in that. You've got the weight hanger, and you've got the steering wheel. That's your basic fork. And at the end of your forks, you have whatever attachments you want to make for whatever harnesses you're going to use. Okay? So that's a simple overview. And like I said, you can either hang them or ground base them. It makes no difference in terms of the construction of them, because the base is a separate entity. Which is why I hate them. They're a fucking pain in the ass. If you think this is a pain, that's just straight construction, and it's a nightmare. So, with no further ado, I'm in the process of shipping this one out, so I'm going to pull out the parts and show you. And I neglected one part on here because I motivate ours a lot. We push them around. Side note. When the main shaft spins, your weights can't spin with it, so you have to bush those or bearing those so that they stay vertically aligned with gravity and you rotate within the collar. The same applies with your bearings, your main support, so you can rotate the shaft and it hangs in one place because nothing can rotate with it. And we use a pusher bar because we have to push these around. So you end up with two strong gentlemen running back and forth or whatever down a slack line on these, with the aid, of course, of the pull on the slack line. Motivating these. So you need a way to push them, and these two guys are holding it, and it's in the middle, but they have to be able to stay here, and that shaft still has to rotate. So you can bearing all of that. Bearings add a lot of weight. We do polyoxymethylene bushings. It's a very hard industrial bearing Teflon plastic material. It's not as soft as UMHW, which is typically called poor man's Teflon. It's much harder and much slipperier. So I churn them out on the lathe and I inset them into the collars so that you have something that rotates internally. A shaft can rotate. It's a bearing, but the block, the pusher, the whatever you've got weight cage will stay stationary. And again, fit is incredibly important because if they're too loose, they get wonky and they will bind up. As it rotates, they will stick and slip, stick and slip. Or if they're too tight, they just won't rotate. Okay, they won't allow the object to rotate within the bushing, and then you'll be fighting them. They'll come around, they'll slip down, they'll come around. It makes for a very wonky setup. And it's high tolerance shit because nothing's perfect on these. You know, tubing, when you buy it, comes with a certain tolerance as well as everything else. So you have to deal with the tubing that's available. It's not like you get a perfectly machined, ultimately smooth surface, dimensionally correct piece of tubing. So you may get a special, we use EN 235 tubing that's special, super hard, super strong, but it's dimensionally correct according to the EN standards, but it still is plus or minus X amount, you know, point whatever. So what you end up with is a bearing that says it's 75 millimeter and a tube that says it's 75 millimeter, and the two won't go together, okay, because of the plus and minuses. It may start at one point, stop, start, stop. You can't get it on, you can't get it off. Remember, you got to take this apart, you got to put it together all the time. You know, you ain't going to store this giant monstrosity as one piece unless you've got a fucking warehouse that you can put it in. And then transporting it's another cunt. So, you know, it's just, the tolerance levels and the functionality of it become quite the exercise. Anyway, that's enough on this bullshit. I'll show you some pieces, and then, maybe I'll splice in a piece of rehearsal footage just to show you a tuning fork of a certain variety. And like I said, you can make them umpteen flavors. You can have them to where you can't do somersaults, but you can puppet people this way, or, you know, by making the fork short. You can make the fork long so that your whole body can rotate end on end within the fork, which means they're going to be X length to allow your head and your feet to clear where the fork comes to an end before it goes on the popsicle stick. So there's different styles, and a lot of times you don't want them so long they can salto because it's an actor. So if they tip over, they want to be able to catch their feet on the back bar so they can stay in a plane while you puppet them around. There's a lot of different catch-22s on building these fuckers. So you try to tick as many boxes as possible. Anyway, like I said, just finished one. Once I get all the parts laid out on the table, I'll try to get everything in here and then just do a quick overview and why and what. And that's going to be Tuning Forks 1A for esoteric mechanical rigging for today. All right? Bye. Hey, I've got to put that fucking button down. I hit it at the wrong time. I've done this 3 times now. You see a tuning fork behind me. It's camera left, my right. Here's the fork standing on the ground. Here's the main shaft, and here's the steering wheel. I'll show you how we design them. We weld these forks up. They're made out of EN 235 tubing. They have a collar on the end. Everything is boxed and gusseted so that it can resist all the forces and various torsions. The tube is first welded and then boxed. The collar is machined on the lathe, and then all of it has adjusters, because otherwise you wouldn't be able to do this. It's just put it together. You know, I could just make it welded on. You pin it through the holes here and all the holes line up. The problem is then you end up with a big welded piece of shit that you can't move around or do anything with. It's 12, you know, it becomes 4 meters long with this on it. And it's just a pain in the ass. So what I've done is make this tight enough to get it on and off, but it brings with it a world of hurt. So we have adjusters so that once it's pinned, you can take the play out of it. Due to the few thou clearance that's in here, there's about 0.8 to 1.10 clearance in here to allow it to come on and off. So you don't fight it and have to beat it off with a hammer or anything else. So that you have adjusters, and all you do is you lift it a bit, snug it down so it doesn't wobble, tighten everything down, but not monkey fuck tight. You know, these things have to be snug, but not brutally tight, or else you deform shit. Like even here on the pipe, this giant piece of 75 mil, I had to weld inserts on the inside, standoffs, because if you put a bolt through this without it and you cinch this down like most stunt guys would, tighter's always better. I mean, I had somebody who fucked up one of their machines because they just kept winding the thing up and didn't look at where the stops were, and they bent it. Same thing would happen here. It needs to be tighter. They fucking crank on it. Now you have a piece of oval ellipse-shaped tubing, and you can't get this fucker off. So, you know, you have to put adjusters, you have to put inserts, you have to do all sorts of shit to allow for that when you do it. The steering wheel is a similar construction. It's an EN 235 collar. Here's the collar. It's fit to a certain tolerance level. And then it's mounted to the wheel. And I've made the wheels myself. Now I just use yacht wheels. They're the right size. I like the carbon. My personal tuning fork is a carbon fiber 3-spoke, but that's just because it's me. But this is a stainless steel. It's got a 25 millimeter shaft in the middle, tapered shaft. So this collar is machined with a 25 millimeter shaft on the end. This wheel is run in on a keyway, and then there are 5 tapped threaded holes in the 12 millimeter insert that they bolt through. So you've got 6 modes of failure. The strongest is 25 mil tapered shaft, and then the weakest is 5 times the bolt pattern. So that then gets brought to the other end, where it just slides on and gets pinned. Period. So now you have your basic tuning fork setup. Okay, you have a steering wheel at one end, you have a holder at the other end, and you're set. Now the big trick here is, which harness you're going to use? Well, A lot of people use a swivel ring in these, so Sutra ring. They're amazing pieces. They're well made. They're incredible. Great. They're a certain size, period. If you start making this adjustable in width, you end up with big construction here to move things back and forth, and you have to gusset and do all of what's done here to allow for a boltable application, okay? That doesn't work well. So what I do is I make a set application that fits a certain size ring. These go in and get pinned with 12 mil pins through here. And the ring, when you need to use it, the performer just is in the ring, steps back up, slides into the slots, and you pin them in, okay? Nothing's pinned right now, so that's why it looks a little funky, okay? So great, they're in the ring, they perform, you do what you need to do. Oh, we want to go to a Sutra harness. Well, you know the old Sutra super swivel plates on the sides with the adjustable. Great. So what I have here is a similar construction. It has two bearings, 50 millimeter apart, and this shaft is locked with collars and can slide in or out to set for the distance and width of your performer's Sutra harness. And again, all they do is step in or out, and it's one aircraft quick pin with an incredible load rating, stainless steel ones, and same as these. These are, 8 tons. So then you can use the same fork with a super swivel harness. Oh, we're gonna go back to the ring. 2 minutes later and 2 bolts later, now you're onto the ring. So here's the 2 pieces, and I've used quick release ones on the outside, bolt ones on the inside because they're close up by the performer. I could put bolt ones here as well, and they come with the package. It's just, that means you better make sure you have the right wrench when you gotta get it adjusted. Normally, you would set them in and adjust it, and that's done. It's for them, it's set. And then the next performer would get in it, you'd reset it. There's options. But you can change 200 millimeter distance per side, and all you have to do is measure from the collar to the pin on both sides so that they're centered, and you're done. You're in. Boom. And if you want, you can, if the performer's doing both, you run them in this, you measure, you set these, they do that. Oh, they're gonna put on the ring. By the time they've changed out of that harness into the ring harness and are in the ring, you've already got these changed, the ring drops right in. Bing, okay? So that's how we roll there. Saw out of the fucking way. Cutting foam, my least favorite job to do to pad these things. So that's how we make these. And everything here is all boxed, welded, triangulated. The big issue, of course, is trying to hold tolerances. As with anything, once you weld it, if anybody's familiar, it turns into a potato chip. You can fixture it all, and the minute you take it out of the fixture, it springs like a fucking, bouncy ball because it's all boring and it's all out of line. So we fixture everything, we weld it with specific heat requirements, and then when we're done, we stress relieve everything because this dimension between the 2 points for a ring is critical. So if you can't hold that tolerance, you're fucked. At least with the Sutra harness, plus or minus isn't gonna matter because you have adjustability. But with the ring, you got one choice, period. It's this wide, center to center on the ears. So we set it for that, we make sure it matches that, and then we go from there. So additional parts would go on there. Here's the bearing hanger. This is the weight hanger. You have 15 choices of hanging weight on this thing, and this has a bushing of high density POM, polyoxymethylene plastic. It's a machinable plastic that's used for bushing material, far better than the UMHW, which is a little too soft. This is very, very hard and very, very slippery. Most of you stunt guys will know it. It's from sliders on your motorcycles. If you run a sport bike or anything, it's got pucks on the end of it. That black shiny shit is POM, polyoxymethylene, and that's what the sliders are made of. It's super hard, can take impact really well, and it'll grind away while you aren't pinned under your bike. My bike over here has currently got several sets of sliders built into it because a year ago, I was pinned under my bike when it crashed. And so this time I didn't feel like having that occur. But that's what this material is. It's super slippery, super hard, and it works as a bearing because none of this is super high speed. And it works great. And it can handle a fair amount of heat if it were to go higher speed, but you're not gonna hook a motor to this and spin somebody on the end of this. I mean, you could, but I don't see that happening. So that's the hanger here. You also have your bearing. housing here, which I won't get into, but it has a large steel insert in the middle. It's 4 plates of 8mm that are all bolted into runners. And the center section is steel with 30mm inserts. And what happens is the 30mm threads are on all 4 sides because you can hang it with these 6-ton crane rings, however you want, either one on each side, one on the top. It doesn't matter. What it does is it distributes the load over all 4 sides, just like a box truss. So you attach it wherever you attach it, but it takes the load on the entire structure. In reality, this is strong enough where if you had something, you could bolt it to on its side and cantilever it. And as long as everything else is strong enough, this would support all of the weight. That's how this is built. So these are your bearings. They bolt in each end. They go on your shaft, and that becomes your bearing section, which goes on here, your weight section, and then we have a push bar section. All of them slide on here with bearings or POM bushings so that you can have them rotate. As this rotates, then the person rotates, but you know, obviously your weights and shit don't. So just a quick look at how we roll and make these and what we've got here. And that's another day in the shop. This one's ready for delivery. It's a little crowded between my bike and a 3 m plus another 4 m tuning fork and all the parts. Hopefully we get rid of those. But tuning forks, trying to make them modular, trying to make them more useful than just a single application welded chunk of shit. Anybody can do that. These become far more effective if you can modularize them and use them for various things. And the reality is, if you wanted to, you could make various lengths of pole on this. This is 3 m. You could make a 1 m, you could make a 2 m, you could make a 6 m. Doesn't matter, because all the accoutrement, the wheels and bullshit, all slides on this same size pipe. So, you know, it's your call. 3 m is pretty good. It's a general purpose for green screen and filming. It works really nice. It's not too long. It's not too short. You know, like I said, on Moon Night we had 6 m ones because we needed the height, and we were working off platforms against green screen with double actors on tuning forks, one over the other. And some people flying in on wires while other actors were on tuning forks interacting with them. You know, things like that. But this one at 3 m becomes fairly useful, and you can, for general use, it's really good. Anyway, that's a tuning fork, and that's today's Toolbox Talk. Take care.